Good afternoon, everyone. This is Mark Albert, Editor-in-Chief of Modern Machine Shop Magazine. Welcome to our webinar sponsored by Fanuc FA America. Thank you for joining us. Our topic this afternoon is CNC Programming Made Easy with Manual Guide I Conversational Programming, Part 4, Advanced Turning and Milling Cycles, Contouring and Thread Milling. Without particular knowledge of G-code programming, it is possible to generate part programs on the shop floor by answering simple questions. Fanuc Manual Guide I Conversational Programming provides this capability for milling, turning, and mill turn centers with Fanuc CNCs. Part 1 of this series gave an overview of the functionality of Manual Guide I. Parts 2 and 3 built on that introduction by reviewing the entire progression of creating a basic turning and milling program with Manual Guide I. Today, as Part 4 in this series, we'll look at some of the complex machining tasks that this programming system simplifies and streamlines. We'll also touch on some of the questions asked most frequently about Manual Guide I. Our presenter this afternoon is Jody Michaels. As End-User Account Manager for Fanuc FA America, Jody Michaels' focus is on servicing and supporting end users to maximize their productivity with the use of Fanuc CNCs. Jody has 35 years' experience in the machine tool industry with various positions in sales, support, automotive applications, and training at machine tool builders, end users, and CNC suppliers. He is a true expert on CNC programming and the functionality, setup, and use of Manual Guide I. As we listen to Jody during the presentation, please feel free to share your questions with us by typing them in the questions pane on your control panel. He will answer those questions at the end of the presentation. Please keep in mind this webinar is being recorded, so you'll be able to view the entire program online later. So thanks again for taking time to be with us for the live program. Here's Jody.
Thanks, Mark. And as you said, today we're doing Part 4 of our series on Manual Guide I. And what we're doing today is some of the more advanced cycles. And the first thing that we want to cover today is thread milling. This is something relatively new in Manual Guide I. And to be honest, it might not be if you purchase a new machine. It's typically in the whole machining cycles within Manual Guide I. But a lot of machines come in from the builders and it will not be turned on. So what you'll need to do is you have to go into your parameters and actually turn it on. And what we're going to do at this point is we're going to go into our NC guide. And I've got it set up right here to where if we go in and look at our cycles right now, whole machining, usually you have center drilling, tapping, reaming, boring, fine boring, back boring. But you see there's no thread milling. So what we need to do to turn that on is we get out of this and we go down. You have to be in MDI to change a parameter. And you go to System. And it's parameter 27095. You type that in, then press the number search key, and it's bit number 5. And for some of you out there that don't understand how Fanuc does parameters, you start from the right-hand side as bit 0, 1, 2, 3, 4, 5. And you can say on with a number 1. It puts a 1 in there. And then now when we go back to our graph, to our Manual Guide I, back to Edit, and we go right shift, back into our cycles. Now when we arrow down, now we have another cycle there, and it's thread milling. So that's how you turn it on. It's probably in all the machines out there, but a lot of times, like I say, the builder won't turn it on when it first comes into your facility. So you can go do that, all right? And typically the parameters are set up to make it work, all right? So at this point, what we're going to do is we're going to go through the procedure for actually using the thread milling. We're just going to make a short little program. We'll make a new program, and we'll say it's 4444, okay? And this will be sort of a review of 1, 2, and 3 also. So it's a good thing. So we go into our fixed forms, and we put our start lines in, and we go up and fill those out. And as we talked about on number 1, it's critical that you have tools set up correctly for whatever cycles you're going to do. And that's one thing about thread milling I want to emphasize, because I've got a lot of questions from people before this webinar about thread milling. What kind of tool do I have to use? Because when you go into your tool offsets page, it does not show within our thread data, tool data, it doesn't show a thread milling tool. All we got is drill, chamfer, flat end mill, ball nose end mill, tap, and we have reamer, boring, and face mill. What you need to use to make thread milling, use the tap type. So we know that tool number 5 is a tap, and it's a 1/2 inch in diameter. So we use tool number 5, so 5, alter, and then 5 alter on the diameter. Then we go down 0 on our positioning in X and Y. Then Z 1 inch, then alter that. Like I said, this is a good review of what we've done before. And then D5 again. And then we'll go down to some speed, say 1,000 RPM, which might be fast. We'll go with that anyway. And then a feed rate associated with that. We want to make sure we always do that. It's good practice within Manual Guide I. Then G54 and alter that. And now at this point, we go back into our cycle for thread milling. And we go down to thread milling. Okay, we select that. And again, it's just like all the cycles that we went over before. Just fill in the blanks. And wherever it's highlighted, that's what it wants. Right now it's saying the thread diameter. It's wanting the major diameter of the thread we're going to mill. So we're going to say this is 1.5 inch diameter. Okay, 1.5 in there. A right or a left-hand thread, we're going to say a right-hand thread. And it can either be metric or unified, so it's either metric or inch. We're going to say it's 1 inch thread, because I think most of us think 1 inch, but you know, whatever. Then we go to cut conditions. And you got 3 different types of threads here within thread milling. And this is great because it more or less covers all the different types of tooling that you might use. One is just 1 revolution. That would be a thread mill that has multiple, it would look like a tap, multiple flutes. Then the second one is thread revolution, and what that is, it's got a single point type tool. And then number 3 is that's the type where there's an insert on it that's got multiple tips on it. So you got 3 different choices. So we'll go with the first, number 1 first, and then the R plane, then a cut depth. And see on this, either plus or minus, we'll say minus 2 inches. A clearance plane of 100 thousandths, a feed rate, and then our approach move. And then this is just the direction of the cut, a down cut, and then it goes past now. I always put 100 thousandths in here. Then we insert that. And then what it'll do is come up and say, okay, where's our points that we want to do? So we'll say X, Y, random points. Goes on the machining center, 0. And then 0, 0, and X and Y. Insert that. And then we'll put an end of program. Okay? So we won't get an alarm when we simulate it. And then at this point, I'm thinking to myself, now I didn't define a blank of what we're going to do. So I want to go back up here and define a blank. So we go start. This just show you how easy this is to do. And we're going to say this is a hollow cylinder blank. We select that, and it's 5 inches in diameter. It defaults back to what I had in there the last time. The inner diameter is this, and it's 2 inches long. We insert that. So that should be all the information we need to actually do a thread mill. So we go simulate and press start. And see it went in and did the hole. And the reason I did a round part is we can cut part of it away with a cut display. And then we can go rotate it to where the cutout is on the other side. So Where do we want to go here? Here, maybe. So see now the cutouts where we can see it. And that's what's good about the rotation. You can get the blank to look however you want it to look. When we press start, we see the tool go all the way through and make one rotation and then come back out. So that's type 1 thread milling. Now, what's great about the simulation at this point, we can go right back and go down to our cycle and press enter. And it takes us right back into it. We go back into the cut condition. And now we'll do this one, type 2. Okay? Then alter. Then we can go in and see in the simulation what it does. Rewind, and then press start. And see how it does. It makes one revolution for every pitch of the thread. So that's what type 2 is. Then we go to group off. And now we're going to go back into the same cycle and then just go through number 3. Okay? Press enter. We're going to edit, of course. Then we'll go and make it the multi-rev and alter that. And again, what it does within the simulation, it will actually show. See, it breaks to 2 inches based on having 5 tips to that insert. It'll know how many revolutions it needs to make to do that. So it's a very powerful cycle. It pretty much covers all the different types of tooling that you might get for doing thread milling. And so it's a very powerful cycle. Very good, very good. Fanuc worked for a good while trying to develop this, and they've done. The engineers in Japan did a great job. So it pretty much covers all the different types of tooling. And it lets you start in the bottom and come out, or it lets you start at the top and go in. But it's very powerful, very powerful. So that's one of the first advanced cycles we wanted to go over. So now the next one that we want to go over within our PowerPoint presentation is we've done the thread milling. Again, within the PowerPoint, it does tell you all the parameters you need to change. And then one we didn't go over when we went back to NC Guide is there. For type 3, you have an overlap parameter. And what that does is when you use the type of tool that has an insert on it, you want it when it makes if the individual, like if it takes 3 passes, you want those passes to overlap a little bit. And this 27451 is that overlap parameter. So it's important that you set that to. Okay, then just fill in all the data like we did. So now the next thing we want to go over is thread repair. This is another very powerful cycle that we have on a lathe. And what this enables you to do is go in and pick up an existing thread on a part and go back and either make the thread longer, repair deformities within that thread, face the end off, and do whatever you want to do. So it's very powerful. But now it's not easy. I can't really simulate this within my NC Guide because it's looking for spindle feedback, things like that. So we're just going to go through the PowerPoint presentation slides to show you how it works. And the procedure on how it works is, first, obviously, you go into MDI, make a threading tool active, whatever tool number that might be. And you set your work offset at the front of the part. Okay? Once you do that, you go into jog, hand wheel, remote, however your machine describes going into a manual mode where you can move it with a hand wheel or with a jog button. Once you get into that, you press right shift key. You know what that is. Talked about that. And you press that once, it'll get you to this screen where it has a repair soft key. So you press the repair soft key, and that will take you to this screen. And this is just our standard thread definition page where you can either do outer or inner, and you have typically 5 different types. And I'll explain to you why you use the different types. The thread general type, that's for if you're going to have a tapered thread that is non-typical. If you got a bastard angle on the thread, you want to use general. Metric, obviously, that's for a metric thread. Unified is for a standard 60-degree thread. Thread pipe thread OD, that's for a 3/4 taper per foot tapered type thread, but only for that taper. You can't change that taper. Then thread internal pipe thread, and that's for a standard. So you select one of those. Then as soon as you do that, it takes you into this screen. And as you can see, you've got 6 tabs that you have to fill out different information in order to do thread repair. The first one is orient. And the important thing you have to remember about thread repair, it's a great feature. However, just turning on the option within the machine to make it work is not enough. The builder of your machine that you have, they have to do ladder development to make sure that it will work with the option. They have to develop their ladder to make sure all the right buttons work. And the reason we don't do it with our standard ladder is because all the machines are different out there. They have different spindle motors. The way it picks up the spindle orient could be different from machine to machine. So it's important that you talk to your builder and make sure he's developed the ladder to make this work. So this is, like I said, it's a very powerful feature. But anyway, at this point, what you do is you press the Orient soft key. And once you do that, here's where it gets interesting. Because this gets into where what you do, you take the hand wheel and you move your threading tool over to where the thread is actually on the part. And you bring it down to where the point of the threading insert is right in the middle of the thread itself. And again, this, when you do this, it's as good as whatever your eyes are. So you want to make sure that you're very careful here and you center it up as closely as possible. I always take a business card and hold up underneath the thread itself, so it'll have a white contrast for when you're lining up the tool in the middle of that thread so you can see it better. That's an old trick. That's an old engine lathe operator's trick. But then once you do that, you get it directly in the middle. You press the Measure soft key, and it'll put a value into this field called Sync Position. Okay, and that's what it's doing. It's lining up the Z-axis with the C-axis of the spindle itself. Then once you do that, then you go to the next tab where you fill in all your just cut conditions, and you've done this before. Then you go into your detail data where you do the RPM, the direction of the spindle, or clearance moves. Then the position, this is just the thread diameter, the front of the part, the number of threads per inch, the length. As you can tell on the length in the page, it's not plus or minus. It's just an incremental value. And then also it asks for the thread depth. And as you can see, it's got a soft key down here that says Calculate. So it will actually calculate the depth of your thread if you wanted to, or if you know the depth of the thread based on your print, you can put it in manually. And then once you do that, it goes to this other screen. The first thing you want to do after you've done that is move the tool out of the thread, because it'll make you do that. Then you press OT off, and what that does is cancels the orient, and then you press Start. Okay? And then it'll go back in and redo the thread. Okay? Very simple. Just those 6 tabs, and then you're done. It'll go back and do the entire thread cycle, and then just wait until, if you want to go back thread. So it's a very good feature. But again, I want to emphasize that your builder has to do some ladder development to make this work. All right? But it's a very good feature, very powerful, very powerful. All right, after this, the next thing we want to go over is engraving. This is something that a lot of people ask about. And again, what we're going to do, we're going to go into our MC guide to go over this. And we're actually going to, again, make a small program to do engraving. All right, so we'll go into Edit, a new program, 5555, create. Now, when you do engraving, again, you have to know what type of tool you're going to use, because engraving, it's either got to be a ball nose end mill or a drill. Those are your two choices for tool selection. So we'll go into our tool offset page, look at that, and we'll go over our tool data, and we got, in number 4, we got a drill, a very small drill, which that's what you want to use when you're doing engraving. You want to use something very small, and I usually use like a very small center drill, okay, because it's very tough. It's made from high-speed steel, so it's going to be a little bit more forgiving. It won't break off as easily as a solid carbide. So we want to use tool number 4, but again, it's got to be either a drill or a ball nose end mill. So we're going to use 4, alter, then we'll position at 0, 0, 1 inch again. Sorry, I know this is a little redundant, but it's good review. And then, obviously, with a tool like this, you want to run it as fast as the machine would go. We're going to say 8,000 RPM. It's going to be a very small tool. And then we'll go over to the feed rate. We'll say 10 inches a minute. And G54, alter. And then we want to do a start again and do our blank. And we'll select the rectangular blank, and it's still got figures from where I did it before. Okay, so now we'll go do a cycle. Okay, and we're going to go, we got hole machining, we got face machining, we got contouring, pocketing, grooving, and under special, it's engraving. Okay, so we select that. And again, so fill in the blank, like all the rest of the blank. For clearance, a feed rate, and then an X walkable plane. The position, asking for our start point. So we're going to say -2 in X. The first one's X. The next one's in Y. We'll say 2 inches. The base position, the top of the part, we're going to say 0. Then it asks for how deep the characters are going to be. And see, and it doesn't show plus or minus. So it's just an incremental value, so we're going to say 10,000. You don't want to put a very big value there. You don't want it very deep because it'll break the tool. The character size, we're going to say 1/2 inch. And the angle, it's just the way it's going to orient that. And we're going to say 0. Okay? And then it asks, what do you want to do? Now, another thing to emphasize here, there's only one font. You can't change this to cursive or some fancy font. You're stuck with whatever it is. So we'll put my name, Jody MP. Okay? And it shows you what it's going to do. And then you insert it. Okay? Let me get that up here. I got red marks up here. For alter and for alter there. And then so with this one line of code here, it'll do that engraving and write that out. So then we go end, and go into program. So now we'll go to auto simulation and press start. See, it showed it. And the reason it showed it like that is because I knew it was going to do that. But what we want to do, we want to go change the rotation of our block. Now if we go to the middle isometric view, and do it again, we press start. You now put it up there. And you know, we can go blow that up if you wanted to see it better. Make it larger. And then redo it. So see, then you can, what's good about the simulation, like we discussed before, is that you've got the capability of fine-tuning the placement of it just based on the simulation, and then you can just go on from there. Okay? So again, it's very simple to use the engraving, but now one thing you might ask is, say you wanted to do part numbers. It won't let you serialize it. Because to be honest, I've been trying to figure out some way where I could increment the number if you're doing a part number, but frankly, I haven't figured it out yet. If there's a way, but I will figure it out if there's a way. Right, so that's engraving. But again, it's very simple. The main thing you got to remember is get the right tool type, either a drill or a ball nose end mill. That's the biggest mistake people make, is that they don't do that. All right? So what we're going to do now, we're going to go back to our PowerPoint. Here. We've done our engraving. Again, there's slides for everything you have to do there also. And then from there, what we want to talk about is, and I'm not going to do anything with it with NC Guide about this, but I have got a lot of questions during our webinars since the first one, where a lot of people have machines out in the field and they're wanting to add manual guide eye, but they don't have the large screen. They got the small 8.4-inch screen. They want to know if it's possible to add manual guide eye to those machines. Yes, it is possible. And within the last few weeks, actually, I've done a couple where I've had to go in. There are certain parameters you got to change to make it work. Because with the big screen, you got 10 keys underneath, and the small one, you only got 7. So you're 2 right shifts and then 5 in between. So there are some parameters. There's 3 pages of parameters here that you need to change to make those work. Okay? I just want to get those in there. I'm not going to go through every one of them because I don't want to go through and change the parameters on my NC Guide. But they're within this presentation where you can see them. And again, I just want to make sure that you're aware that if you have a machine out there that's got the small screen, you can add the manual guide eye, the advanced version manual guide eye, to your machine and make it. Okay? So there's 3 pages for that. Now next, what I want to talk about is some things that typically, if I do training or if I talk to people, that call me about manual guide eye, there are some parameters that make things much easier to do. And because I get phone calls all the time and people say, well, when you were doing your webinar, you had something on your screen that's not on mine. So there's like 7 of them here that I want to go over to make sure that you understand that if you go turn these on, it will make things much easier for you when you do your programming on manual guide eye. Now the first one that I said I want to go over is thread data access. And what that does for you is, say you're in edit and you're in a program, and this probably won't work on your machine, but when you highlight a line where there's a tool number and a diameter number, see how it shows a drill. It shows what that tool actually is. So say you have a program that, even if it's something that you wrote offline, if you just find a line with the tool data in it, and you get down and press input, it automatically takes you into your tool offset table onto your tool data screen on that number tool. So you know exactly what that tool is, the geometry of it, and you don't have to, because usually what you do, you go right shift 3 or 4 times until you finally got to your tool offset button. That's okay, but this is much easier. You just highlight the whole line, press input, and it goes directly to that screen. Okay? So it makes it much easier. All right? And also, we talked about earlier, was within our cycles and the whole machining was the thread milling. A lot of times you'll get a machine and it won't have the thread milling feature turned on. Again, that's a parameter 27095. You go into System, for an MDI. This one, 27095, bit 5. Turn that to 1, and that'll bring treadmilling up. Also, 27451, number search. That's the overlap. For when you're doing treadmilling in type 3, you want to put a number in there. That's the number of teeth that's on your threading insert, how much it'll overlap. If you tell it 1, it'll overlap 1 tooth. Okay, it's important that you set that also. Another one that you need to turn on is 27,000 bit 7. That's for embossing. And what that does is within Manual Guide I, usually when you do one enter, go back to our graph. I'll show you where this is. We go into Edit, into our cycle. See now up here has old machine, face machine, contouring, embossing. Okay? What embossing is, and I know all of you have noticed this, like if you're doing a contour mill, where it's going around and milling a circle out of a square, a lot of times it'll do a lot of passes that are air passes, where it's not taking any material because it's going all the way around. With embossing, you go in and define the actual outline of the rough part, then it'll only remove material where there is material. So it'll make the program much more efficient. Much more efficient. Okay? So, and then another one that you want to look at also, if we get out of that, is 3401, number search. And what this is, it's 6 and 7, where it has GSC and GSB. For the Fanuc control, there's 3 different programming languages. There's A, B, and C. Usually these are only changed on the lathe, but it's important that you know these because different builders will use different languages. I don't know how they decide, but they do. The easiest way on the lathe to determine which one it is, you can look here. If they're both zeros, it's program language A. If it's 1 in bit 7, it's program language C. If it's a 1 in number 6, it's B. But on the lathe, the way I always tell, it's based on if you use a G50 to limit your RPM for constant surface speed, that's program language A. If it's the G92, that's for program language B. But it's a very, very nice option to have. Okay. Now at this point, what I want to do is get back down to this. So we want to go back to our PowerPoint presentation. We sort of went over all those. And again, this shows the different screens, how they look when you turn things on. All right? Rough without in-facing, rough with in-facing, without residual, with residual, the embossing tab, the program language A and B, and the differences. All right, so at that point, I'm sort of going through all those fine-tuning parameters that I do. And now I want to sort of go over some 10 of the frequently asked questions I get all the time, whether it's through emails or phone calls or whatever. And while I'm going through this, what I want to do, again, I want to go back into NC Guide so I can sort of show you the answers. Okay? And we'll go here, go back to graph, and the most frequently asked question I get all the time is because different builders can make access to this is, usually when you start up a control, you'd be on this screen. This is the standard Fanuc G-code screen. To get access Manual Guide I, usually the builders will either use graph function key or the custom 1 or custom 2. Or sometimes there'll actually even be a hard key over here with your single block and block skip that'll say MGI. I'd say probably 90% of the time it's either going to be graph, custom 1, or custom So that's a frequently asked question. So on mine, press graph to get into it. Okay. Question number 2 is, how do you change the blank size? Okay. People ask me this all the time. And to do that, you go into your Start, and you have a tab up here that says blank. You arrow over to that, and that's where you determine what your blank size is. You select one of these blanks, fill in the field, just press Insert, and it puts it in your program. But what it always does, if you don't determine a blank up front, it will default back to whatever the last one that was drawn. So you want to make sure you do that within that. Okay. Another frequently asked question is, how do I get my fix forms into my machine? To do that, you got to be in Edit, and usually you would come up into this screen. You go right shift 4 times, 2, 3, 4, and then press Settings. Register fixed form sentence for milling. Select that. And then this takes you into where you can make new ones, alter them, delete them, or input or output. What I'm going to do, I'm going to delete these. So don't ever press that standard button. What it says is, are you sure current is overridden by standard? Yes. See what it does, it deletes them all. So be careful before you ever do that. But then to input them, press Input. And on my memory card, I have a file called form.dat. Press Input. And again, it comes up and says, are you sure? So you got to press the button twice in order to do that. Yes. Input. Now they're back. So that's how you input them. Now, the next question that goes right along with that, how do I change one? To do that, all you do is just arrow down to one you want to change. Alter, and then you can just, arrow up and down between them, and then just go over and change whatever you want, and press Alter. All right? So that's how you both input your fixed forms, then change them. Okay. Another question I get all the time is, I'm trying to simulate a program, but it doesn't show a tool. The reason that is, number 1, you have to put a D word in the program for it to pick up whatever data you have in your tool table. It's geometry of the size of the tool. And you have to describe the tool also, whether it's a flat end mill and the orientation of the tool also. You got to have all this data set up. You have to use a D word in order for it to show it. Okay. And along with that also is, how do you make a new tool? Okay, tool offsets. You just go into one where we don't have any data. You put a value in the size of your cutter. We'll say it's 3/4, so half of that. And then we'll go over here and make it a tab. It's as easy as that, making a new tool. That's how you create a new tool in the tool data table in Manual Guide I. All right? Now, we created a tool, and people are asking me all the time if the tool offsets that we create in Manual Guide I, are they used on the G-code side? Yes, they are. They're used on both sides. So the data that you put here, your geometry, your tool length, your cutter comp, it does pick all that. And also people are asking all the time about whether it will simulate a G-code program. Yes, it will. You can import a program from a CAM system and simulate it on Manual Guide I. All right. Then also, people are asking about an undo button. Does it have an undo button? And so right on the screen, you got to be in Edit, obviously. So like if I accidentally deleted this line, as soon as I deleted something, the undo button comes up. If I want to just put it back, I just press undo. That puts it right back where it was. Okay. The last question I have, and this one is number 10 on my list, but I get asked it all the time, is, does Manual Guide I have a material table? within Manual Guide I, no, it does not have a standard material table. But within your fixed forms, you could set something up to where with specific materials you could set up spindle speeds and feed rates and everything with a fixed form. But it does not have a material table where once you do a cycle or a program where it goes up and picks out cut speeds and feed rates based on different types of material or tooling data or anything like that. There's nothing like that within Manual Guide I. Okay? So at this point, that's all the last of my 10 frequently asked questions and, you know, fine-tuning the parameters. So at this point, I'm going to throw it back to Mark, or maybe we can cover any questions that we might have from people out there in the audience.
Okay, I'm ready to go here, Jody. Thank you. That was very interesting, as all of these parts of the webinar series have been. So thank you for an informative presentation. Yeah, let's go to some questions from our audience here. I'm going to combine two of these because they both have to do what you're able to do with Manual Guide I on a lathe with live tooling and a C-axis. And one of them is, are you able to thread mill on that kind of machine?
Yes, there is an option for a live tool lathe, just like on the mill, that you can do thread milling on the OD also. Yes, as long as you've got the right axes, you know, on a live tool machine.
Okay.
Yes, it is possible. It is possible. It is possible.
So how about engraving on that same kind of machine?
Yes.
With
the engraving is totally possible, both on, you know, Mark, obviously, if you have a live tool lathe, there's different configurations of live tool lathes. You can have one where there's 3 axes, where you have X, Z, and then the C axis on the spindle, where you're going to be doing polar coordinate programming. So yes, you can do engraving that way. And then you can have a mill turn machine where it's got a Y-axis. And then it's going to be more like a mill lathe. So you can do it both ways. But yes, you can do engraving also. Yeah.
Okay. Here's a couple more questions about engraving. I believe you did say that you can't change the font for engraving, correct?
No, there's only one font. Only one font.
Okay. Is that likely to change in the future? Do you think there's some plans to make it possible to change the font?
I'm not sure how you would go. I guess it's possible, but, you know, I'm not really, frankly, that's probably a little bit above my pay grade. I'm not really privileged to. I've never heard that they're going to change that part.
Okay, that's.
I guess it could be. I guess it could be possible, but I haven't heard anything to substantiate that.
Okay. Now here's a question that you can probably add to your list of frequently asked questions. I know Manual Guide I is available on the control of the machine. Does Fanuc offer this for the desktop version?
Yes, yes, and you're right. That should be one of my 10 notes. I mean, we do offer a couple different options. I mean, you have NC Guide, where there's 3 different versions of that, Mark. You have the academic version to where it's great for students to where you can study and practice at night, practice programming, but it's limited about the input and output capabilities. And then you got NC Guide to where it's fully, you can program, take the programs out, put them in a machine and run them. And then you got NC Guide Pro where you could actually take the ladder and the parameters out of an existing machine and put it into that to where you can simulate the machine you have in your shop on your desktop totally. Okay, so you got those 3 versions. And then we also got one where it's Manual Guide I only offline. There's still a version of that. So there are 4 versions that are, several different prices, obviously. So yes, it's totally possible to have something on your desktop that you could program using the same type of software like what I'm using here for the demonstrations for the webinars. So what I'm using is NC Guide, the middle version of NC Guide.
Okay. All right. Another question here. How do you create a contour in the XY plane?
Okay, that's very simple, and that's why I sort of left this setup, is within, when you would go do a cycle, you know, a contour cycle. Here, you know, whether it be an outside or an inside or something like that. Once you fill out all those cut parameters, Mark, then you go, it will prompt you into this figure, a contour figure. And within those, you can do a square, a circle, a track, or a free convex figure. You know, if it's something that you know exactly what the sizes are, like a square or a circle, those are easy. But if you want to draw something, you go into the X free convex, and it's just a matter of drawing it out. You know, it says, okay, it's convex. Where's my start point in X and Y? 0 and 0, 0, and it's minus 1 inch deep. I'm not going to go all the way through it, but see, then it brings up all these lines, and then you just go through and draw the lines, the arcs, corner radiuses, corner chamfers. As long as you got a good print, you can go pretty much define whatever the part might be, and it'll do figuring for you. You know, if you don't know all the exact points, it'll trig it out for you, and it will even, you know, I've had it used for by people where it'll find mistakes on a drawing, or if they've got a drawing that it says that it's connected. Manual Guide I mean, it's just like sort of like having a mini CAM system. So, but that's how you do it. And then once you get done, you press Create. It creates the geometry, and then you go on from there, and you machine it.
Okay. Another question here. Is there a fixed form for chamfering on a multitasking machine with, you know, Y, W, Y, and Z axes? I'm not sure. I'm not sure I get the question, but maybe you can take a stab at that.
Yes, I think there would be, actually. I mean, you do have, within the different cycles, you do have, so, you know, you got outer wall contouring, and, you know, based on, it is possible to do that. Yeah.
Okay.
You have
another case.
Go ahead.
I was going to say, is this something you need to check with the machine tool builder to start out, so you have that capability, you know, to make sure you have that capability?
Right. Because, you know, it all has to be configured correctly. You know, when the machine would come in, that should have all the different axes configured correctly within Manual Guide I. So there are a lot of parameters. Because usually Manual Guide I will come in configured on a base machine. You know, and a lot of times if you're getting into multitasking type machines that are really truly 5-axis stuff, you know, it'll do 4. You can't do 5 within Manual Guide I. But the 4 for what you're talking about there, that would be enough to do the camper like what you're talking about there. Because you got to go, it's got to go until the configuration is standard. But yes, it could do that. Yes, we just have to set it up correctly.
Okay. I just want to remind our audience. Okay, just to remind our audience that we still have some time left. So if anyone wants to enter some questions in the question pane, we'll go ahead and we'll get to those. We'll answer all the questions, even if we don't get to them while we're on the air. Remember, the webinar is being recorded, and it'll be available online, so if you can't stay for the whole session, you can catch up later. So let's get back to our questions here. And this one says, can you, quote, project a pocket shape on the OD of a cylinder to be end milled out?
On a cylinder? Yes. Yes, you can do that.
Okay. Anything we know about that, or any tricks, tips on that?
No. I mean, it's a fairly, it's just using cylindrical interpolation to do that. So yes, okay. It's more than possible to do that, both on a lathe and on a machining center.
Okay,
So they,
as straightforward as the...
yes, it's very straightforward. Very straightforward.
Okay. All right. Let's get to this question. Will manual guide eye offset for the diameter of a tool during milling?
Yes, it will. Although, and this is another one of those questions, Mark, where I get asked this all the time, and the reason is because it's a little different with manual guide eye than it is, say, with a CAM system. Because with a CAM system, it'll generate a G41 or a G42 for where it offsets the tool based on whatever the diameter of the tool is. With a manual guide eye, when you call up your tool, in your tool data, it tells you the diameter of the tool. So it looks at that when it makes all your XY moves. So as long as you would leave it in the conversational mode of program, if you went and changed the size of your tool, it'll regenerate the code based on whatever that size is. If you convert it to a G-code program, it does not spit out a G41 and 42, and it's only using whatever the size was when you did the original program. So if you want to be able to change the size of your tool, you want to leave it in the conversational format. Okay? So it's important people know that. It's important that they know that.
All right. I want to get a couple more questions in here. Can the set point in the thread repair be used in a program?
Oh, where you measure that point? Yes, you can use. You could. Yes, yeah, I think I know what they're asking. Yes.
Okay.
Because, go ahead.
Well, interpret that question for us, Jody, so the answer makes a little more is more valuable to us.
Well, I think what people are wanting to find out is, and it's a great question, because with thread repair, you know, you're doing this within a cycle that's in manual guide eye. But you're actually orienting the machine, you're orienting the C-axis of the spindle with your linear axis, your Z-axis. And that doesn't matter whether you're on the G-code side or the conversational side. So if you would do that at the beginning, you go in and orient that and measure that distance, and then go run a G-code program, it would still pick up the thread. It would still pick up the thread. And I think that's what they were asking. So
okay.
What a lot of people want to do, Mark, is they don't necessarily want to use the threading cycle within manual guide eye. They want to use their G76 threading cycle that they use all the time, and it will work for that. It will work for that.
Okay.
Okay.
All right. Looks like we have time for a couple more questions. But would you use the same process to put in a keyway in a shaft? And I think that same process might be one we discussed in a previous question.
Yes.
Yeah. Would that be like the?
Yeah. Yes.
Yeah. Okay.
Yeah.
All right. Then, how about, can you set your work shift in manual guide eye?
Yes. Yes. Yes, you can. And what's good about it is it still does exactly the same thing as what you would do on the G-code side. It's just a little bit prettier pictures. So, and I'm showing it right now where you're going into your work coordinates, and say you want to set your X, you just press enter. You want to measure, and it brings up another calculate offset. You have to tell it what your target is, like if you want this to be 0, and put that in there and then input. Of course, it's not going to change because I haven't moved my machine. But yes, you can do that. Like I said, the pictures are just a little prettier than what's on the standard side. But it still picks on both the conversational and the G-code side.
All right. How about using my Renishaw probing cycles while I'm in manual guide eye?
Yes. Yes. What's good about that is, you know, sort of what we talked about on part 1 about where you can set it up however you want it. not necessarily how I want you to set it up, it's the way you want to. Within your fix forms, what you can do, and I've had several people do this, they actually download their Renishaw probing cycles, so they're usually relatively short, and they put them in their fix form. And then, when they're doing their programming, they'll just go grab one and insert it right into the conversational programming and use it right within Manual Guide I.
Okay.
Okay. So it is capable of doing that.
All right. Is it possible to slow down my feed rate in specific spots in turning?
Yes. Yes. Both in milling and turning, actually. You can do that. And it's where, we're describing how you drew a figure. If we go in and do a continuous figure, a pre-convex, we go into that. When you would draw something, I'm just going to do something like that, 0, 0, 0, and then minus 0.5, then say OK. And say we do a line here, going somewhere, left and up. Okay. Whenever you do that, alter, it'll bring up an attribute on the element where you can slow down the feed rate on each individual attribute. So you can slow down the feed rate all the way around the outside of something. Just pick out where you want the slower feed rate to be. So it's very easy to do that. It's just called the attribute. I'm not sure why they called it that, but that's what it does.
Yeah, okay. Hey, Judy, I'm going to try to squeeze in one more question here from our audience. Would you use the same process when using a DRAP or a Dreamer? And a DRAP or Dreamer, that's the combination drill tap and a drill reamer. Those are, types of cutting tools.
Right. Yeah, with that, that's a good question. That's one I've never thought about before, because you have to have it tied to the right feed rate in order for the tap to work correctly. So, I don't know. I'm going to have to get back to them on that. I don't know.
Okay.
I don't want to say anything I'm not sure about.
Okay. Well, that's certainly fair enough, Jody. And then to wrap this up, this last question. Can I just type something in manually in G-code and simulate it?
Yes.
With me? Oh, okay.
Yes, that's one of the good things about Manual Guide I. There's a lot of guys out there that maybe the cycles within Manual Guide I doesn't totally fulfill what they want to do. They want to do just something simple, where they just want to come over and make an X move or a Y move or whatever move. And, I've had people call me and say, well, can I just type it? Yes, just go, call the tool up, type in what you want to do. As long as you've got your tool data correct, which, I've been beating everybody over the head about that. Get your tool data right. You can type in whatever you want, and it'll simulate it on whatever you type in. And it's a great feature because, you can do that or use the cycle. So it's a very good feature.
Okay. Jody, I guess we're about out of time here, so I just want to thank you again for presenting the slides and answering all these good questions. For those attending this afternoon session, you can contact Fanuc FA America if you'd like more information. I think we can get that contact screen up here in a second. Yeah, in the meantime, I just want to remind everyone, if you've missed any of the previously broadcast parts in the series, you can find all of them on our website, MMS Online, under the Webinars tab. And you can just pick the ones you want to catch up on. So I really appreciate the time that everyone in the audience has taken with us this afternoon, and I hope you found it worthwhile. Thanks for taking part. This has been a real fun series of webinars to be a part of. So I want to thank Jody in particular and thank all those who've arranged this session and helped it go real smoothly. So this concludes our webinar this afternoon. Please have a great day, everybody. This is Mark Albert at Modern Machine Shop Magazine, signing off.